Hi, welcome to this lesson on calculus, the factor and remainder theorems. Let's have a look at using the factor theorem, question 2. So we want to factorize the cubic expression x cubed minus 7x minus 6. Now notice it is of the form of a cubic expression. We can rewrite it as x cubed plus 0x squared minus 7x minus 6. Okay, so the coefficient of x squared is 0 here. Alright, so first of all, the constant term here is negative 6. So all the factors of negative 6 are plus minus 1, plus minus 2, and plus minus 3, and plus minus 6. So in total we have 8 different factors that we can check. So let's hope that we get lucky on the first one. So if I do p of 1, that's 1 cubed minus 7 times 1 minus 6. But that's 1 minus 7 minus 6, which is negative 12. That's not equal to 0. So therefore, we can say that x minus 1 is not a factor of that expression. What about negative 1? Well, negative 1 cubed minus 7 times negative 1 minus 6. Negative 1 cubed is negative 1. Negative 7 times negative 1 is positive 7 minus 6. Well, that's going to be 0. So therefore, x plus 1. So always the opposite sign here of the number. So that is a factor. So we'll do logical inspection, and then we'll do polynomial long division to check that both solutions make sense. So for logical inspection, I know that x cubed plus 0x squared minus 7x minus 6, that must be the same as x plus 1, which is a factor, times a quadratic expression. Now to get an x cubed, I need an x squared term. And to get a negative 6, I'm going to need a negative 6 here at the end. So I just need this bx term, and I'm done. Well, again, I'm going to compare the x squared terms here. So on the left, we have 0x squared. And on the right, we're going to have x times bx is bx squared. And 1 times x squared is x squared. And those are the only terms when expanded out give me x squared. So now I have, if I take x squared to the left here, I have negative x squared equals bx squared. And therefore dividing both sides by 1, or x squared rather, I get b equals negative 1. So this expression can be factorized as x plus 1 times x squared minus x minus 6. But this quadratic expression can also be further factorized. So it's x plus 1 times x minus 3 times x plus 2. Because when I factor that, if I expand that expression out, then I get back x squared minus x minus 6. So that is the full cubic factorization of that term. However, let's do it through polynomial long division and double check. So through polynomial long division, we take that factor x plus 1 and we divide it into x cubed plus 0x squared minus 7x minus 6. Okay, so if I put x squared on the top here, I get minus x cubed plus x squared. So subtracting those terms, 0x squared minus x squared, that's negative 1x squared, and then the x cubed terms cancel out. I bring down my terms, negative 7x minus 6. So now, if I do minus x here, so subtracting, negative x times x is negative x squared, negative x times 1 is negative x. So the negative x squared minus negative x squared is 0x squared. Negative 7x minus minus x is negative 7x plus x. So that's negative 6x. And then bring down your negative 6. Okay, so far so good. Now to get rid of the negative 6, if I put negative 6 here, then I'm subtracting. Negative 6 times x is negative 6x. And then negative 6 times positive 1 is negative 6. So negative 6x minus negative 6x, that's 0x. And then negative 6 minus negative 6, that's just 0. So we get this entire quadratic expression with a remainder of 0. So that's exactly the same quadratic expression that we landed up with using logical inspection. Alright, so knowing how to do both ways is really important because you can quickly double check that your solution makes sense, as well as by expanding out that factorization and checking that you get the terms on the original expression, x cubed minus 7x minus 6. Alright, so that's how we would do this type of question. I'll see you in the next one.